Okay, we're taking a look at a breakout of my 4-axis shoulder pair here. This is probably going to be in the rear. I got a 6-inch width between the right and left sides. These two braces, they're made out of plywood, and they're, as I sort of flush out their shape, but hopefully those will be aluminum by the time I'm done. You have a turning axis right here. Could be a motor right over here that drives this, and then there'll be a motor on the leg that drives this axis. We're looking at this from the rear right now. This is the back of the shoulders, the rear shoulders, and this will be the right side, and then this will be the left side. And of course I had that pulled out. It's actually just like a bicycle headset. I'm using these 1-inch bearings from Activotics with these 1-inch collars, and then this is a 1-inch aluminum tubing. I drilled this out so I can mount just about anything I need on the drive side, and I think I really like the way I have this configured. You can kind of see that I made some clearances there. I made some clearance cuts so this thing has a lot of motion. We'll take a look at that in a second. Here's I dismantled the left so you can see what it is. This is a 1.5-inch aluminum tubing with an 1/8-inch wall, giving me 1.25 in the inside, and it holds these bearings just right. And you can see how I have it assembled on this side. I think I'm really in love with this shoulder design, this rear shoulder design. These are kind of like the rear hips, because it's simple. It was easy to put together, and it's very, very strong and stiff. If I try to move these, they just, even with the crummy plywood, they're just so rigid. And once I put the aluminum in there, they're going to be more rigid than they need to be. But what I've got going here is, if you were going to build a smaller robot, you could actually use the 6-inch leg width, and you could actually just put your leg plates all the way down from the center. I'm side mounting mine because I want a wider leg width, but I'm going to stay with the same width because this is going to be sort of part of an organic robot. This sort of mocks out the femur, where you have your ball joint right here, and then there's like a 45-degree drop down to the outside on each side, and then the femur goes straight down. So that's kind of why I'm going with this side mounted leg here. And you can see that, take a look at it from the side here, you can see that this is about, these plates are 30 degrees from each other. I was trying to make a triangle to help make this more rigid, and so I could squeeze it in to the character a little bit better. But this is going to be positioned just about like that. These are going to be 30 degrees down. This is going to be straight up and down, and this has got a 30-degree walk to it. And both of these hip joints move very well. Like I said earlier, I'm going to have a motor right here, either positioned like this or like this, depending on whatever I'm squeezing it into. And then this axis is going to be run by that, and then this axis is actually going to have a gear fixed, firmly attached to this position here, and the motor is going to be inside of this leg with a belt or a chain that throws this back and forth. And I think with that, whatever pose control I want to give it, it's going to move really well. I can give it a stance, and I can go back and forth, and that just looks and feels really nice. So I'm looking forward to getting this together. And what's cool about this is, even though I built this for a specific robot, this is such a robust, simple build that 2 of these could be used to build a quad. You could face them forward or backward. You could put any motor you want on there. This is such a nice, rigid, solid thing. It wasn't very expensive at all. Aluminum tubing is pretty cheap. In the end, I'd like to see these pivot plates aluminum, and these aluminum. Now, if I can TIG these up, I'd love to see that, but I'm a ways away from that. But there we go.